For these, all of the rest of these here are dealing with infinite geometric series. So now we're talking about these infinite geometric series. And I just want to find the sum if it exists. So the thing I always do is identify the R value. Here, the pattern is I'm multiplying by -2. And remember that I can only do the formula. The formula that I get from the previous page is S equals A sub 1 over 1 minus R. I only do that formula if my R values are between -1 and +1. And so since the -2 doesn't fall into the acceptable range, I don't even do the sum of this one. I can't find the sum. It doesn't exist, which is why this stipulation is here, because this one diverges. So I say it diverges, it doesn't exist, and I don't even find the sum from there because I can't. Okay? If I look at the next one, this time I have an R value of 5 over 7, and that does fall in the acceptable range. That is between -1 and +1, which means this infinite geometric series will have a sum. So I say S equals A sub 1, which is the 8, over 1 minus R, which is this guy. And now I just have to simplify this. That's 8 over. 1 is like a 7 over 7, so when I subtract, I get a 2/7. And now dividing by a fraction, the same as multiplying by the reciprocal. So it looks like that's going to give me a 28. That's it. Okay? So sometimes I can find the sum and sometimes I can't. It really depends on the R value. So when I look at the next one, I look at the R value of 1/4. That's in the acceptable range, so I can find the sum. So that's going to be, let's see, A sub 1, which is the 1 over 32, divided by 1 minus R, which is the 1/4. And when I do this subtraction that's down here, that's 1 over 32 divided by, that's going to be a 3/4. Again, dividing by a fraction is the same as multiplying by the reciprocal. And I can multiply this out, cross-reduce a little bit. I want to leave this as a fraction. The 32 and the 4 reduce to a 1 and an 8. And now I multiply straight across, so I find out that my sum on this one is 1 over 24. Okay? If I look at the next one, again, this time I have to identify the R value, the thing I'm multiplying by. And if you really have trouble and you can't see it, just take one term divided by the term before it. Okay? You can always work backwards to the R value. So here, if I'm working backwards to the R value, I just take one term, which is like the 3, and I divide by the term before it, which is the 4. So now I know to get from a 4 to a 3, I multiply by 3/4. And you can check it. 4 times 3/4 is a 3. 3 times 3/4 is a 9/4. So my R value this time is indeed a 3/4. A sub 1 is the 4. And so now I can find the sum because that R value falls in the acceptable range. 1 minus the 3/4. And now from here, that gives me a 4 over 1/4, which, again, dividing by a fraction is the same as multiplying by the reciprocal. So that gives me a 16. And that's it. I apply the same thing to this next one, except this one's just written in my sigma or my summation notation. But when I look at this guy right here, this entire equation, is in the format of my formula A sub n equals A sub 1 times R to the n minus 1. And so just looking at this thing right away, I can identify the R value as being 1/3. So my R value this time is 1/3. The A sub 1 I can identify right here as being the 9. And then I ask myself that same question, does the R value fall in the acceptable range? It does, so I can find the sum of this one. I do S equals 9 over 1 minus R, which is the 1/3. So that's S equals 9 over 2/3, which again, dividing by a fraction is the same as multiplying by the reciprocal. And so that gives me a 27 over 2. And that's it. Okay? The next one, I do the same thing. It's in that same format. When I look at this equation right here, I can see right away that the A sub 1 right here is the 6. I can see that the R value is the 4/3. And 4/3 doesn't fall in my acceptable range. It's greater than 1. It's too big. So I'm going to say this one diverges, which means I can't find the sum, so I don't bother with my formula. Okay? For these, we want to write these as fractions. Remember, we can rewrite these as geometric, an infinite geometric series. But if I have the whole thing repeating, I've got a really great shortcut here. If I've got one value repeating, this time I just have a 7 repeating. And I put that 7, if there's just one value repeating, I put it over a single 9. If there's 2 values repeating, I'll put it over 2 9s. If there's 3 values repeating, I put it over 3 9s. So this one, just one value repeating, so I just put 1 9 underneath, or a single 9 underneath, so it's 7 over 9, which doesn't reduce, so that's my answer. Okay. Same thing here, I have 2 values repeating this time, so I put those 2 values, which is the 5, 2, over that amount of 9s, so 2 9s, so 9, 9. And then I look at this thing and say, okay, is this going to reduce at all? And this one's not, so it's a 52 over 99. Next one, same thing, I've got 2 values repeating, so I put those 2 values over that many 9s, so over 9, 9. This one can reduce. The reach divisible by 9, so that reduces to a 7 over 11. Okay. The next one, I have 3 values repeating, so I put it over that many 9s. And then I want to reduce this thing. Each of these is divisible by 3. So when I do that, let's see, that's going to be a 47 over 333. This is where it gets a little bit tricky, but really the shortcut here is to think of it this way. I think of this as a 0.5 plus a 0.04 with a bar over it. Okay, and really when I think about this fraction, because I want to be able to use the same shortcut, when I think about this fraction right here, I'm going to think about it in 2 ways. First of all, I'm going to think about it this way. If I have something like a 0.04, that'll be the same thing as like 0.4 divided by 10, okay, to move the decimal one more spot. So if I have 0.04 with a bar over it, it's the same thing as 0.4 with a bar over it divided by 10. By the same logic of getting 0.04 is the same thing as 0.4 divided by 10, 0.04 with a bar over it is the same thing as 0.4 with a bar over it divided by 10. And so when I really think about that, if I have 0.4 over 10 like this, 0.4 repeated forever, if I look no further than the examples, the 4 examples I just did, 0.4 repeating forever is the same thing as 4 over 9. There's one thing being repeated, I put it over a single 9. And I can apply the same thing here. I'm just going to rewrite these as fractions. The 0.5 is 1/2. The 0.4 with a bar over it is 4 9ths. So what I end up with is 4 9ths divided by 10. And now I just have to simplify this a little bit. And I'll just simplify it as I go here. 4 9ths divided by 10 is the same as multiplying by 1 over 10, multiplying by the reciprocal. So I get 1/2 plus 4 over 90. And now I just have to get common denominators. I'm going to multiply this one by 45 over 45. That's going to give me a 45 over 90. Plus a 4 over 90, which I find out then is a 49 over 90. And that doesn't reduce at all, so I'm going to leave it that way. And I can easily check any one of these by just plugging into my calculator and seeing if I get that decimal. Okay? The next one is essentially the same thing. I'm going to break this into a 0.6 plus a 0.021 with a bar over the 21. And just like I did before, I think of this guy in the same manner. This is like if I had a 0.0121, that's the same thing as 0.21 divided by 10. So if I have a 0.021 with a bar over it, that's the same thing as 0.21 with a bar over it divided by 10. And so if I think about it that way, the 0.6 plus is going to be a 0.12 with a bar over it divided by 10. Again, dividing by 10 just moves the decimal one place. And now I start converting these to fractions. This is 6 over 10. This guy right here, 0.21 repeating forever, is the same thing as 21 over 99. The 21 over 99 reduces to a 7 over 33. Dividing by 10 is the same as multiplying by the reciprocal. So I get 6 over 10 plus 7 over 330. And now I have to get common denominators. For this one, I have to multiply this first guy by 33 over 33. So when I do that, I get a 198 over 330 plus the 7 over 330, which is going to give me a 205 over 330, which of course I can reduce that. They're each divisible by 5 for sure. So I get a 41 over 66. And once again, that's easy enough to check on my calculator by just dividing those and seeing if I get the decimal that I was hoping for, and I do. Okay? Hope this was helpful. Good luck on your quiz.